Hello and welcome to lesson 2.5, Algebraic Proof. This lesson may look a little bit different. I'm using a different slide format, so if you need to pause to copy anything down, please make sure you pause the video, give yourself enough time to do so, and follow instructions as we go through this. So before we start the lesson, again, why don't you take a few moments to work through this warm-up, solve each of these equations, make sure you follow your steps carefully, and push pause so you can do that, and then push play when you're ready to begin. Alright, hopefully you've had a chance to go ahead and solve these. Let's take a look at what we should have gotten for each of these answers. 3x plus 5 equals 17. Solving that gives you x equals 4. Subtract 5 from both sides, 3x equals 12. Divide by 3, 12 divided by 3 is 4. Number 2, r equals 12.2. Number 3, t equals negative 5/2 or negative 2.5 or negative 2.5. Either way you wrote that answer is okay. Number 4, n equals negative 38. You would need to multiply both sides by 5 first. And on this one, distributing first and combining like terms, you should get y equals 15. Alright, let's take a look at today's objectives for algebraic proof. We will review properties of equality and use them to write algebraic proofs, and we will identify properties of equality and congruence, and we'll talk about what all these things mean in this video. Your vocabulary word for today is proof, and so we will begin by defining that word. A proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. An important part of writing a proof is giving justifications to show that every step is valid. We'll get this from our use of the law of syllogism, getting from one step to the next, to the next, to the next. It's important to think of these proofs as either chains with one link starting the chain and following link by link until you get to the end, or you can also think of them as stair steps. You have to take one step at a time, and with each step being a step of the proof with a given reason. So let's review some properties of equality. The addition property of equality states if A equals B, then A plus C equals B plus C. This is what allows us to add the same thing to both sides of an equation in order to solve that equation. If you're adding the same thing, C, to both sides of this equation, it remains balanced. Subtraction property of equality, very similar to addition. If A equals B, then A minus C equals B minus C. This allows you to subtract something from both sides to solve. Multiplication property of equality. If A equals B, then A times C equals B times C. Division property of equality allows you to divide both sides of an equation by the same thing as long as what you're dividing by does not equal 0. Then we have some other properties that will be very useful as we continue to talk about proofs. The reflexive property of equality is a property stating that a value A equals itself, and we will actually use this several times. It may seem very simple, but it will be very useful in doing our proofs. A equals A. When something equals itself, that's the reflexive property. Think of looking at yourself in the mirror. You see yourself. You are yourself. Symmetric property of equality, which can often be confused for the reflexive property, states if A equals B, then B equals A. But this is different than this reflexive property because it involves taking an equation and flipping it around. It is symmetrical down to the equal sign. The transitive property of equality, this will sound very much like your law of syllogism. If A equals B and B equals C, then we can say A equals C. Then lastly we have the substitution property of equality. If A equals B, then B can be substituted for A in any expression. So let's take a look at our first example, but first remember the distributive property is also going to be used. In example 1, we want to solve the following equation. 4m minus 8 equals negative 12. Write a justification for each step. So as I click through each of these steps, make sure you're copying them down carefully. The first thing you want to do is write the given equation, and right out beside it, you're going to write what's in blue here, given equation. You can write just the word given, and that will also be sufficient. The first thing we would do in solving this equation for m is to add 8 to both sides. So we would write it like this, plus 8 here, plus 8 here. The reason we're able to do that is the addition property of equality. Then we would write our results. The reason for that is simplify. Then we would divide both sides by 4. The reason for that is division property of equality. And then we would simplify to get our result that m equals -1. Now take a few moments to try part B and follow the steps we just did, but with this equation, 1/2 t equals -7, and solve this equation for t, justifying each step. First, you would write the given information, just write the original equation, and out beside it write given equation, or just the word given. Then the first thing we need to do is multiply both sides by 2. So somehow show multiply both sides by 2, multiplication property of equality, and then we would simplify to get t equals -14. Next, let's take a look at example 2. What is the temperature in degrees Fahrenheit F when it is 15 degrees Celsius? We're going to solve the equation F equals 9/5 C plus 32 for F and justify each step. Okay, first we need to understand the problem. The answer will be the temperature in degrees Fahrenheit. You don't have to write this part down, just listen and follow along. So we're going to list the important information. We want to start with the given equation. We know the value for C should be 15 degrees. So we're going to make a plan. Again, don't feel like you have to write this down. Substitute the given information into the formula and then solve the equation for the remaining variable. So here's where we would begin showing our work. This is to be written down. First, write your original given equation. Now we know that C equals 15 degrees, so before I go any further, I need to substitute 15 in for the value of C using the substitution property of equality. Again, make sure you justify each step like this with a reason. Now we can start to simplify. In simplifying first, we do 15 times 9/5. The 5 and 15 will partially cancel. 5 divided by 5 is 1. 15 divided by 5 is 3. 3 times 9 is 27. So we have F equals 27 plus 32. Once again, we can simplify just to get F equals 59. So we know that is the answer to our problem. The last step in problem solving here is to make sense of our answer. And F equals 59 degrees. That is a Fahrenheit degree temperature, different than our Celsius degree temperature. We can check our work by simply going back and making sure that we've done our math correct. We can substitute 15 in for C and 59 and see if it works, and both sides would be 59 when simplified. So that is our answer. Like in algebra, geometry also uses numbers, variables, and operations. For example, segment lengths and angle measures are numbers, so you can use these same properties of equality to write algebraic proofs in geometry. So we have a helpful hint here, a reminder that AB represents the length of segment AB. So you can think of AB as a variable representing a number. So let's practice solving some equations when we are applying some things we've already learned from geometry. We want to be able to write a justification for each step and be able to solve for the value of x using this. Well, we have segment NM and MO that make up segment NO. So if you will remember, we have a segment addition postulate that states NO must equal NM plus MO. These two lengths added together give you the overall length. So we can write this and justify it by the segment addition postulate. Then we can substitute what we know. 4x minus 4 is NO. 2x is NM, and 3x minus 9 is MO. So we can replace those. We can simplify. 2x plus 3x is 5x. Now we can start solving by subtracting 4x from both sides. We get -4 equals x minus 9. And then we can add 9 to both sides and get 5 equals x. We can do another problem using angles. Remember that two adjacent angles will have measures that add up to the sum of their combined angle. So we have our angle addition postulate that states the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. So I can substitute the values that are given. ABC measures 8x. So after this substitution, we should be able to solve for x. Why don't you take a moment or two and solve this equation for x. Alright, hopefully you have been able to get these steps. These are the steps I took. We can simplify first. Then doing the subtraction property of equality, we get negative 11 equals negative x. Once again, we subtract 9x from both sides, and we get this. Then we divide both sides by negative 1 or multiply both sides by negative 1, and we have used the multiplication property of equality if you multiplied by negative 1. And then also, sometimes we will add in this last step to put the variable on the left, the number on the right, which uses the symmetric property of equality. Here's another reminder from Chapter 1 that segments with equal lengths are congruent and that angles with equal measures are congruent. So we have some properties of equality that will also apply to congruence. And so we have reflexive, symmetric, and transitive properties of equality that will have their corresponding properties of congruence that will look like this. The reflexive property of congruence says figure A is congruent to figure A itself. Here's an example. And we abbreviate it as the reflex period prop period of, and you can just write the congruent symbol. Next, we also have a symmetric property of congruence. Figure A is congruent to figure B, then figure B is congruent to figure A. We can just switch the order of that congruent statement, and it's abbreviated like this. And we also have a transitive property of congruence. If figure A is congruent to figure B, and figure B is congruent to figure C, then figure A is congruent to figure C. This again is very much like our law of syllogism that allows us to be able to say this for a transitive property of congruence. Please remember, numbers are equal and figures are congruent. So let's take a look at our last example. We need to identify the property that justifies each statement. We have angle QRS is congruent to angle QRS. This angle is the same as itself. It's like it's looking at its reflection. So this is the reflexive property of congruence. Reflexive property of congruence. Next, we're told the measure of angle 1 equals the measure of angle 2, so the measure of angle 2 equals the measure of angle 1. We have a line of symmetry through this equal sign that allows us to turn it around, and it would be the same. And since we're talking about equality, this is the symmetric property of equality. We have the statement segment AB is congruent to segment CD, and segment CD is congruent to segment EF. So, segment AB is congruent to segment EF. That would be the transitive property of congruence. And the last one on this slide, 32 degrees equals 32 degrees. These are number values that are 1 is the same as itself. Excuse that interruption. This would be the reflexive property of equality. You have a couple more listed in your note packet that are not on these slides. Go ahead and take a guess at those, and we will talk about those in class. Hopefully you have been able to understand these algebraic proofs a little bit better. Again, know the properties, know what they mean, and know how to use them, and you'll be just fine.